Hello everyone and welcome to a last discussion on springs in India, and this is of course part 2, but this is going to be the last on springs. And today we are going to discuss especially about hot springs, which has got a lot of scope, not only from medicinal values, but from religious point of view, but also from thermal energy point of view. So, where these are located, how they function and so on. So, we will more focus today on this hot springs. As you know that the hot springs or hydrothermal springs are also called, and which are having potential for geothermal energy. So, these are also called geothermal springs. So, different terms are being used, but hot springs generally when temperature is not too high, but geothermal springs we can discriminate when temperature is quite high and vapors are out of coming of that one. One example of this thermal spring at Tapovan in Chamoli district of Uttarakhand is shown here, and you can see that the water is boiling when this photograph was taken. And these are the perennial springs all the time. The water is coming on the surface and it is almost at the boiling temperature, and then it flows downstream. So, these springs are produced by emergence of geothermally heated groundwater onto the surface of the earth. That means the heat, the heat to heat up this water is coming from deep down the earth, and that is the relation. That is why they are having lot of dissolved minerals in them. So, groundwater when it is heated either by shallow intrusions of magma, that is molten rock in volcanic areas, or by circulation through faults to hot rock deep in the earth's crust. So, if there is a fault, geological fault, the water might be going down through that fault openings and then can come up somewhere else as a very hot water or as a hot spring. So, some thermal springs or geothermal springs or hot springs are not all the time related with the volcanic activities. They might be just because of tectonic activity, that is the fault. And water is heated by convective circulation, that means the water, groundwater percolates downwards and then reaches to the depth of a kilometer or more, where the temperature of rocks is very high and the normal temperature gradient of the earth's crust. Now, when we say that it goes to a kilometer, these are just simple estimates. It might be going more than many kilometers deep in the earth and then coming on the surface as hot spring. So, ultimate source of this heat which is heating our water or creating hot springs is the radioactive decay of naturally occurring radioactive elements in the earth's mantle and the layer beneath the crust. So, beneath the crust and then in the top part of mantle where these radioactive actions are or activities are happening, especially the radioactive decay, and that is one of the reasons for causing the heat or heated water or hot springs. As earlier mentioned that these hot springs water which is coming out of these springs having large amounts of dissolved minerals, and hence sometimes having medicinal value or medicinal utilization. And that is why a lot of people, those who are having problems with the skin disease and other things, they go, because if you go near these hot springs you would find that there is a completely different smell which will be coming, and especially the sulfur smell comes out of these springs because it can dissolve quite easily relative to other minerals. So, or other elements. So, chemistry of hot water which people have done a lot of work ranges from acidic sulphate springs, which I have just mentioned, the sulphate, with a pH as low as 0.8. So, this is quite acidic in that sense. Or sometimes you can have alkaline chloride springs which are saturated with silica, or to bicarbonate springs saturated with carbon dioxide and carbonate minerals. So, depending on geologic rocks or conditions, the chemical quality or chemistry of hot springs water can change accordingly. So, all kinds of minerals can be found on different hot springs. Some springs also contain abundant dissolved iron also, and you would find that the surrounding rocks where they or the surrounding surface or outlet where these springs are there, you would find very red color deposition, that is because of iron minerals. So, the minerals which are being brought by these hot springs also feed the communities for extreme foliaces, microorganisms adapted to extreme conditions, and it is possible that life on the earth had its origin in hot springs. So, that kind of interpretations of hot springs is being done or have been done, and there are microorganisms which can survive even in this high temperature and high acidic conditions as well. And some of these microorganisms might be very friendly to human skins. That is why it is a strong belief that these hot springs are very good for disease for the human skin. As you can see here on the figure that this is a radioactivity or religious belief, and this is the very famous hot spring. In earlier discussion also I mentioned this Manikaran which is located in Himachal Pradesh, and you can see that the vapors which are coming out, it is a really hot water, very hot water, and even they cook the meal which is served in the Gurudwara during the langar. So, that kind of heat is coming out, and since it is a very cold place normally, so people go and enjoy such kind of bath in these hot springs. And in this Manikaran area at several places there is a small market or other things, and in several places you would find the vapors are coming out of that. So, humans have made use of hot springs for bathing, relaxation as you can see in the photograph, or medicinal therapy for thousands of years, because these springs have been bringing hot water from deep from the earth since ages. However, some are not hot enough that immersions can be harmful, leading to scalding or potentially death. So, some are maybe very hot and that can create problem to humans or other animals. But normally when we see like in Manikaran or other places, the temperature is not that high that directly it will harm the human body. So, water issuing from a hot spring is heated as we have just discussed geothermally deep from the earth with a heat produced from the earth's mantle or lower part of the crust. And this heat up of the water can take place in two ways. One is the areas of high volcanic activities. Magma may be present at shallow depth in the earth crust and at the lower part of the earth crust, and the groundwater is heated by these shallow magma bodies and rises to the surface as hot springs. Other way the water can get heated is the areas that do not experience volcanic activity. However, the temperature of rocks within the earth increases with depth. It is a normal condition in the earth. That is why in the core we say the rocks are not in solid form, they are in the liquid form or semi-liquid form or viscous. So, the rate of temperature increase with depth is also known as geothermal gradient, and this geothermal gradient is people use also to estimate that at what depth different rocks might have formed which are exposed today on the earth's surface. So, this geothermal gradient understanding is very important, and not only for hot springs, thermal springs, but for other kind of studies also in geology or in our field of earth sciences. But from engineering, groundwater engineering point of view, these are many of these are having very high potential for the geothermal energy generation. And if you are having a setup something like that, that you are having a distinct recharge area, hot springs are there, and the steam vent is also there, then these can be used to generate hydrothermal energy. A few efforts have been made in India at one or two places where they have installed such turbines which can drive, that steam can drive, which is coming out of these hot springs, but not at large scale in India. But like countries like Iceland and other in Europe, they are having quite good production of electricity or energy through hydrothermal wells or hydrothermal springs. So, if as we know that if water percolates deep enough into the crust, it will be heated as comes out on the contact with the rock. But how the water will go deep into the crust, that is only through some geological structures, and obviously some faults have to be there. So, that water first goes inside or deep in the crust, maybe few kilometers, and then comes up on the surface as hot springs. So, this process takes place along faults which I have mentioned, where shattered rocks and beds provide easy path for water to circulate to greater depth. And as water will go deeper, it will produce more heated water on the surface. So, this is the basic principles here, because geothermal gradients, if you see that is very high or the high temperature is provided at depth. So, there is a kind of direct relation, deeper you go, more the temperature you get. Now, if we see a topographic section, and this is a scenario of basaltic flow like in Deccan Trap. So, these faults they are providing water, and this example is from our Indian setup, that is from Western Ghat, and Deccan Trap flows can also be seen on the top part, and there might be a circulation of meteoritic water inside in the basement area. Contact zone is also there. So, like Tural hot springs or Rajwadi hot springs are located because of the water which is going down in the crust and coming up through these faults. So, this topographic section is indicating the possible mechanism of origin of hot springs with different circulation paths, where currently no volcanic activity is taking place. So, much as we know that much of the heat is created by decay of naturally radioactive elements, and that keep happening inside the earth. So, as per some estimates, 45 to 90% of the heat which is escaping from the earth basically originating from this radioactivity or decay of elements mainly located in the mantle, top part of the mantle. So, here in the diagram you can see that the heat flow in temperatures which is shown here, and that is terawatts is given here, and time in giga annum, a unit of present time equal to 1 million years. And as you can see that the decay though occurs, but still this decay can produce very hot water through these springs. So, major heating producing isotopes in the earth are potassium 40, uranium 238, uranium 235 and thorium 232. So, these are the isotopes which are the major heat producing isotopes or substance inside the earth. Now, we have discussed one where volcanic activities are occurring and where no volcanic activity is there. Then this heat flow flows through the crust by a slow process of thermal conduction, but in volcanic areas the heat is carried to the surface more rapidly by bodies of magma. So, in case of volcanic areas, that means the magma is coming from mantle or core towards the crust, and it is carrying a lot of heat or temperature. So, there whatever the water or groundwater which will encounter in between will get heat up. So, this is one of the mechanisms which is involved in creation of such hot springs. So, as we have discussed that a hot spring that is periodically jet waters and steam is called geyser, and the best example of geysers are in Iceland, though name of the country is Iceland, but it has got very good geysers and very good generation of geothermal energy through these geysers. So, periodically it is not continuous like in our country, the hot spring continuously discharging the hot water, but here sometimes there is a huge jets which comes up on the surface and of course steam, and then we differentiate through as compared to hot springs these as geyser, and these are the very good from energy generation point of view. So, an active volcano zones such as Yellowstone Natural Park in USA, magma may be present at shallow depth. So, this is what I was saying, when magma is present which is coming from core or mantle part coming near the surface, and if it is there then water will get heated up. So, if a hot spring is connected to the large natural cistern close to such a magma body, the magma may superheat the water in the cistern, raising its temperature above the normal boiling point. And this is what happens in case of when magma is not much deep, but quite close or in the bottom part of the crust. And in volcanic areas definitely such scenarios are very much possible. Now, specifically now we will focus on hot springs in India. So, Himalayan geothermal springs which cover about 10,000 square kilometer of the area in Garhwal region of Himalaya show a significant discharge of carbon dioxide rich water. In the previous discussion, we showed a concern that these hot springs are contributing carbon dioxide to the atmosphere, and that may be directly or indirectly related with global warming or climate change also. But anyway, this is what, so we will focus on mainly in this discussion hot springs in India, and in of course in Himalayan regions we are having a large part 10,000 square kilometer area. So, through these hot springs of Uttarakhand, this carbon dioxide degassing or removal of dissolved gases from liquid, especially water or aqueous solutions, flux is nearly 7.2 10 to power 6, it should have been 10 to power 6 molecules per year to the atmosphere, which is a big supply of carbon dioxide through these hot springs. And such a carbon dioxide degassing should be taken into account to assess global carbon outflux in the earth atmosphere. So, the hot springs are one of the contributors, we can say one of the contributors of carbon dioxide into the atmosphere, and therefore, in any models which are related with the climate change and temperature rise should also account for the carbon dioxide which is being contributed through these hot springs. The earlier cross section, geological cross section I showed about these two hot springs, Tural and Rajabadi hot springs of Maharashtra, India, which is in Deccan Trap terrain. On the surface, of course, you are having Deccan Trap. So, volcanic activity held million years ago, but not currently. But the water through the faults, it is going deep in the crust, and then it is coming and creating hot springs. So, these are the locations of hot springs in part of Maharashtra, Nevel, and then also the Tural, and nearby you are also having Rajwadi, and Aravali hot springs are also there. Now, hot springs and active seismic belts of Koyna warm region, the Varna region, this is another location for the hot springs because of seismic activity. So, we have seen earlier we have discussed two types of or two sources or reasons of hot springs. One is the volcanic activity, another one was the geological faults or other things. But another one is the seismic activity, which is again related with geological movements along the geological faults. And in Koyna Varna, which is having a reservoir, and reservoir induced seismicity we observe there on regular basis, and there also hot springs have been found. So, 18 hot springs areas in the west coast of Maharashtra have been identified, and that is mainly Deccan Trap areas or basaltic terrain. Manikaran hot springs, another photo is there, and the important why I am showing again, because of this cooking rice in the boiling water, and the same rice is served in the langar in the Gurudwara, which is also shown on the left figure here. So, and as you can see, the vapors are all around are coming from rocks, and they are of course carrying lot of carbon dioxide as well. But it is a cold place, so people feel quite pleasant here near to these hot springs and enjoy there also. There are more lot of hot springs in Uttarakhand, Gangnani hot springs, Gaurikund hot springs, which is in the base of Kedarnath, and I personally have also been to Gaurikund. Then there are some other hot springs are there, Tapovan is there, and Tapta Kund Badrinath is also there. So, these are the well known hot springs being visited by the religious purposes and also for skin diseases. But as I have mentioned, just one site have been developed, not in Uttarakhand but in Maharashtra, for the geothermal energy. Otherwise, these are not yet any possibility to generate geothermal energy from that, though some efforts can be made. Now, one other point which is not directly related with hot springs, but it is related with springs overall. In earlier we have mentioned that like Koina Varna region, which is seismically active region, hot springs are found. But in case of Chamoli earthquake, which occurred on 29th March 99, these springs locations are also shifted due to any seismic activity. So, human interventions can change the location and discharge or even the quality of water which is coming out of springs. But other reasons might be also influencing the location, discharge and quality of water, and that another one of the reasons is earthquake, which we will see the example. So, here this is the area, and there is a small watershed in Teri Galwal district, which was studied from a spring point of view and what happened during that time. So, we have taken the satellite data, some topographic maps to know what were springs existing before the earthquake event and what happened after the earthquake event. So, the source of data and details of data are here, topo sheet surveyed much before earthquake occurred in 99, but the latest surveyed topo sheet we had of 1981-82, just before the earthquake, and other. So, we wanted to locate the position of earthquake, position of springs before the earthquake, and later then we found that there were like the springs, the first option, the springs were existing before the earthquake, and springs which were existing in the 1998 in the satellite images also, through the indication of growth of vegetation and other things. So, if we see that this is again shown in a different way, 1998, and springs locations have changed quite significantly. So, in 81 it was the what was the land use change. So, it is also influencing land use. So, land use of the area. So, springs are also influencing the land usage. If water is available, it might be used for human consumption, animal consumption and growth of vegetation or agriculture. If water is not available, things will change. So, here what you are seeing, that forest part has reduced, the agricultural land has reduced, however, the afforested land has increased. So, this is another reason why many springs are drying up in the Himalaya, because the uprooting of trees or forest is happening. And these are the springs which are shown here, which are how they were controlled by different lineaments or geological structures, and again two different years dates are there. And these are the springs in terms of how the slopes, what kind of control the slopes had on the springs, that is also shown here. Plus what was the aspect which was controlling these springs can also be seen here, and many springs generally you would find they are facing or slope where the springs are located towards the south direction. The reason is that maximum human interventions in hilly regions are in southern facing slopes, because you get the sun all the time, and roads have also been constructed. So, when roads are constructed or widening of road happens, then you cut the topography and you expose the groundwater, and sometimes you disturb or create a new springs also. So, likewise the springs are also shown here, and then other curvatures and other things have also played very important role. Now, this is about the co-seismic spring flow changes attributed to March 29, 1999 Chamoli earthquake. So, this is the point which I was trying to emphasize, that even an earthquake event can disturb the spring discharge and location of springs as well. And we have seen, and through these publications we can also see that how the springs have changed, and whether all geological setup are supporting the change in springs or only some geological setups are. So, if you are having in the background, if you are having geological map structures, you can understand what has happened and what not has happened. So, these are the estimated regions with a pore pressure due to compression have increased plus signs, which you are seeing here in this part, and then decreased, that is the minus sign here, and the major role is being played by the fault. So, some springs are showing more discharge, some springs are showing a less discharge after the earthquake. So, earthquake can influence, as I have said earlier also, can influence the location of a spring, can influence the discharge of a spring, and also the quality of water in the spring. But these are the major source of water in hilly regions where human lives, animal lives and agriculture practice are based on. So, that is why it is very important to understand all aspects related with the springs, which I tried in all these three discussions to understand the role of springs in lives, and what is the role of groundwater, and how different conditions are creating hot springs, how they can be used, where they are there, and so on. So, with this I end this discussion. Thank you very much.